So in this situation, we have two coins attached to either end of a thread and drawn between a pulley. What is happening here is there is a tension force between the coin and the string, the thread, as well as gravity is pulling down on both coins. Now, common sense will tell us that if we let go of both coins, the loonie will fall down and the dime will fly up, simply because the loonie has a greater mass, so there will be a greater force of gravity acting on the loonie. The question we're being asked for is to determine the magnitude of the acceleration of the coins. To do that, we need to determine the net force on the system, because this will not be simply like dropping a loonie out of your pocket. The dime will actually be counteracting some of the force of gravity. So we can find the force acting on each coin and then find the net force at that point. So the force on the loonie would be mass times acceleration. The mass of the loonie, 6.99 grams. However, we cannot use mass in grams in a calculation. We need kilograms. So we'll divide that by 1,000, 0.00699. And the acceleration experienced by the loonie is because of gravity. So we'll actually be using 9.8 as the acceleration here. Multiplying that out, going to 2 sig figs, we get 0.068 newtons of force on the loonie. We can actually go and we know that this loonie will be being pulled down, so we can assign the direction now. Exact same process for the force on the dime. Mass of the dime being 2.09 grams. Again, we'll need to divide that by 1,000, 0.00209. Acceleration is due to gravity, so 9.8. Going to 2 sig figs, the force on the dime will be 0.020 newtons, and the dime will be moving up. So the net force on the system will be the combination of these forces, 0.068 newtons down from the loonie and 0.020 newtons up from the dime. We can't simply add these because we need them to be in the same direction, so I'm going to leave the down force as positive. And if I flip the sign on the up force and change the direction, we will get a net force of 0.048 newtons down. Now that we know the net force on the system, we can determine the acceleration of each coin. So for the loonie, we know that F net equals MA. The net force, 0.048 newtons. The mass of the loonie in kilograms, 0.00699. Dividing that out, going to 2 sig figs, we get the acceleration of the loonie as 6.9 meters per second squared, and that will be down. Exactly the same to find the acceleration of the dime. We know that F net equals MA. Net force on the system still 0.048 newtons. The mass of the dime in kilograms, 0.00209. Dividing out again to 2 sig figs, this will give us 23 meters per second squared, and the dime's acceleration is up.